Hello students, welcome to a new session. Today we are going to start mesh analysis. Let's start. Now, where mesh analysis is concerned, it is a technique to find solutions for a network. Now, when is this mesh analysis used? Mesh analysis is used if there are large number of voltage sources. It is applicable for planar network. When I say planar network, any network that can be drawn on a plane surface without crossovers. As I'm saying, you can note it down, okay? Now, when we say planar network, I will give you an example of planar network. This is an example of a planar network. Another example of this is planar network. This planar network, everything is on one plane surface without any crossover. Now, if we consider a non-planar network. I'll show you how a non-planar network looks like. This is a non-planar network. You can see there are a lot of crossovers over here. So this is an example of non-planar network. You will see that as I am talking, as I am delivering the lecture, you will please note it down. Now, how is mesh defined as? Mesh is defined as a loop which does not contain any other loops within it. That is a definition of mesh. Again, I repeat, mesh is a loop which does not contain any other loops within it. Now, how do you check? Simple steps whether you can apply mesh analysis to a network or not. The first step is you have to check whether the circuit is planar or not. That is your first step. Second step is you have to write Kirchhoff's law equations in terms of unknowns. and you have to solve them so that you get the final solution. Let's start with the equation. Number of mesh currents is equal to number of mesh equations and number of equations is equal to branches minus nodes minus 1. Hence, number of mesh currents is equal to branches minus nodes minus 1. Let's just brief this up. What is mesh? Mesh is defined as a loop which does not contain any other loops within it. How do you check whether a network has to be analyzed with mesh analysis? First you check whether the circuit is planar or not. Second, you write Kirchhoff's law equations in terms of unknowns. Solve them to find the final solution. Number of mesh currents is equal to number of mesh equations. Number of equations is equal to branches minus nodes minus 1. So finally, number of mesh currents is equal to branches minus nodes minus brackets node minus 1. Let's start with some problems. Okay, take down the first one. You have to write first problem. Write the mesh current equations in the circuit shown below and determine the currents and determine the currents. Let's draw the circuit. Now in finding the mesh current equations, what we need to do is we need to redraw the circuit diagram. So we will redraw the circuit diagram. With mesh currents in it. Now we can assume the direction of current. So I am taking one mesh current I1 in this direction. I am assuming I2 also in this direction. So let us write the mesh current equations. Now the mesh current equations, let us take the first loop. This is your loop 1 and this is your loop 2. Since there are two currents flowing, you will get two mesh current equations. So let's start with the equations. Now if you see over here, we will start this way. So how is it? 10 volts minus the KVL loop. 10 volts minus I1 into R1, that is 5 I1. Now over here, this part, when we are coming across this 2 ohms, so what will happen? We will write minus 2 times. Since we are taking into consideration loop 1, it will be I1 minus I2. Now why we are writing I1 minus I2? Because 2 is actually common between loop 1 and loop 2 is equal to 0. Let us repeat. 10 volts minus 5 I1 into 5 ohms minus 2 times I1 minus I2 is equal to 0. Let us open up the brackets. So it will be 10 minus 7 I1 plus 2 I2 is equal to 0. So minus 7 I1 plus 2 I2. 10 volts I'm taking on the other side, so it will be minus 10. I'm changing the sign, so it will be 7 I1 minus 2 I2 is equal to 10. That is your first equation. Clear? Now let's go to the second. Let's go to the second mesh current equation. Now how do you start with the second mesh current equation? Since we are taking this part, let's start with the second equation. The second equation is minus 10 I2. Why we are taking minus 10 I2? In the direction of current, it is negative. So minus 10 I2 minus 50. Now minus 2 times I2 minus I1 is equal to 0. Now you all will ask why it is I2 minus I1. Since we are considering loop 2, so it is the I2 current minus the I1 current, and since 2 ohms is the common resistance between loop 2 and loop 1, we take both the currents into consideration. So we will solve it. Minus 10 I2 minus 50 minus 2 times I2 plus 2 times I1 is equal to 0. So what do you get? 2 I1 minus 12 I2 minus 50 is equal to 0. So 2 I1 minus 12 I2 is equals to 50. This is equation 2. So let's solve both the equations. Okay, when we are solving both the equations, take the first equation, 7I1 minus 2I2 is equals to 10. The second equation is what? 2I1 minus 12I2 is equals to 50. So, since we are finding out the value of I2, we have to eliminate I1. So, how do you do that? Just cross multiply with the terms of I1. So, the first equation I'm multiplying by 2. The second equation I'm multiplying by 7. So, what do you get? 14I1 minus 4I2 is equal to 20. Next, what we get is 14I1 minus 84I2 is equal to 350. Changing the signs, what do we get? I1 gets eliminated. What do you get is 80I2 is equal to minus 330. So I2 is minus 4.125 amperes. That is your I2 current. Now let's solve for I1. We all know that the first equation, what is the first equation given as? 7I1 minus 2I2 is equal to 10. So we already know what is the value of I2. That is minus 4.125 is equal to 10. So what do you get? 7I1 plus 8.25 is equals to 10. So 7I1 is equal to 1.75. So I1 is 0.25 amperes. Now you all will ask why I2 is minus 4.125. Why is this negative sign? And here, why is it a positive sign? That means we have assumed the current I1 in which direction? This direction. Yes or no? So what is I1 of yours? Positive value. That means it is telling us that whatever direction of current we have assumed, I1 is correct. Now I2, what we have assumed? What is the direction of current what we have assumed? Is this way. And since it is negative, what is the value of I2 we are getting? Negative. It is indicating to us that the direction of current has to be in the opposite direction. That's it for this problem. So it is I2 and I1 we have already found out. Let's go to the next mesh current problem. Determine the mesh currents. Determine the mesh currents determine the mesh current I1 in the circuit. Let's draw the circuit diagram. Please copy the diagram. Now let us assume the direction of currents in all the three loops. The previous problem what we did was only two loops were there. Over here there are three loops. So this is I1, this is I2, this is I3. So let's start. Let's start with loop 1. This is loop 1, loop 2 and loop 3. Let's start with loop 1. Now when we talk about loop 1, it is this loop. So it will be 50 volts. Minus 10 I1 minus, now over here if you notice 5 is common to loop 1 and loop 2. So it will be minus 5 times I1 minus I2. We have taken I1 minus I2 because we are finding of loop 1. So it is the first current minus the second current, and 5 ohms is common between loop 1 and loop 2. Next, minus 3 times. Now 3 ohms is common between which loops? Loop 1 and loop 3. So it will be minus 3 times I1 minus I3 is equal to 0. We have taken the potential, again I am repeating, it is 50 volts minus 10 I1 minus 5 times I1 minus I2 minus 3 times I1 minus I3. Since we are following the direction of current, we have given this minus signs. Okay, so let's open up. So it will be 50 minus 10 I1 minus 5 I1 plus 5 I2 minus 3 I1 plus 3 I3 is equal to 0. So what will be your first equation? 10 plus 5 plus 3. So it will be minus 18 I1 plus 5 I2 plus 3 I3 is equal to 0. Sorry, is equal to minus 50. Changing the signs, you will get it as 18I1 minus 5I2 minus 3I3 is equal to 50. This is your first equation. Let's go to loop 2 equation. So we are going the direction of current. So it will be minus 5I2 minus I1 minus 2 times I2 minus 10 volts minus 1 times. Now since 1 ohm is common between loop 2 and loop 3 and we are taking loop 2 into consideration, it will be I2 minus I3 is equal to 0. So when we open up the bracket, what we get? Minus 2I2 minus 10 minus I2 plus I3 minus 5I2 plus 5I1 is equal to 0. So finally you will get 5I1 minus 8I2 plus I3 is equal to 10. That's your second equation. Now let's go to third equation. Third equation is, we are considering this loop. Since 1 ohm is common between loop 3 and loop 2, so it will be minus 1 times I3 minus I2 minus 5 volts minus 3 times, again 3 is again common between loop 3 and loop 1, so it is I3 minus I1 is equal to 0. So when you open up the bracket, minus I3 plus I2 minus 5 minus 3 I3 plus 3 I1 is equal to 0. So what you get is 3 I1 plus I2 minus 4 I3 is equal to 5. So this is your equation number 3. Now let's solve with the help of Cramer's rule. So according to Cramer's rule, we will solve the equations. Now let us start with the first equation. It is I1 is equal to, according to Cramer's rule, it is delta 1 upon delta. Now when we are talking about delta, what will be your delta? Delta will be all the I1s, I2 and I3 together. So what is your I1 term? 18. I2 term will be of the first equation. Okay, 18 minus 5 minus 3. What of the second equation? It will be 5 minus 8, 1. Third equation, it will be 3, 1 minus 4. This is their delta. Like how do we find the determinant part, right? Now since we want to find out the value of I1, so wherever I1 is there, you replace I1. See here, what is there? This is I1, right? 18, 5, 3. This is I1. You replace it with the values. Which values now? 50, 10, 5. So what it will be? 50, 10, 5. And the remaining terms will remain the same. So it will be minus 5, minus 3, minus 8, 1, 1, minus 4. So let's solve this part. So how do you solve it? Determinant form. 50 into minus 8 into 50, it will be what now? 8 4s are 32 minus 1 plus 5 times what it will be? 10 into 4, that is 10 into minus 4, that is 40. 5 into 1 is minus 5, and last term will be minus 3 into 10 plus 40. I well understood this. I repeat again. You take this term 50. So 50 means this row and this column is not considered. This row and this column is not considered. Take the other term. So it will be 8 4s are 32 minus 1. The second term, when you are taking into consideration, it's always minus. So minus into minus of 5 becomes plus 5. So this top row and the second column is not considered. So it will be 10 into minus 4, that is minus 40, minus 5. And the last term is minus 3. So the first row and the third column is not considered. So it will be 10 minus of minus 8 into 5, that is plus 40. The same thing. You continue over here. So what you get I1 as 3.3 amperes. Units are very important. Now let's start with I2. So how do you do I2? First, write what is the determinant part. That is 18, 5, 3, minus 5, minus 8, 1, minus 3, 1, minus 4. Now since we want to find out I2, we are replacing the second column by the values. Which values? Which values are we replacing it by? 50, 10 and 5. So second column gets replaced by 50, 10 and 5. The rest of the columns remain the same as the determinant. That is nothing but delta 2 upon delta. So what do you get? You will get 18 into minus 40 minus 5 minus 50 if you solve the determinant, okay? Upon 256. Sorry, 356. So what is the answer to this? I2 is 0.997 amperes. That's how you find out I2. And let's find out I3. I3 is, again you write the determinant with respect to Cramer's rule. 18, 5, 3 minus 5 minus 8, 1 minus 3, 1 minus 4. So over here what will happen is we are replacing the third column by the values 50, 10 and 5 because we are finding I3. So it will be 18, 5, 3, same as your lower column, minus 5, minus 8, 1. The third column gets replaced by 15, 10, 5. So if you solve it, you get 18 minus 40 minus 10 plus 5 times 25 minus 30 plus 50 upon 5 plus 24 upon 356, that is I3 is 1.47 amperes. This is how you solve the MASH equations.